sitting down because I'm getting older and my back's not as good as it used to be. I'm actually really excited to be here tonight. He did a fine introduction. I'm the founder and CEO of CodeEnvy. Out of curiosity, has anyone ever heard of CodeEnvy before, other than through the San Diego Jug? One person, okay. We're doing a great job with marketing. CodeEnvy is actually, has anybody here heard of a company called Exo Platform? They compete with Jive and get the same person. Okay, one other person. Okay, well, in CodeEnvy actually spun out, is a spin out of that company. We actually were started in 2013, very beginning of 2013. We're about 18 months old now. But some of the IP that we started with began in 2009. And it started off as a very simple project, and it was attempted to be an IDE in the browser. And they had 3 guys that were kind of kicking the tires on it. And it originally started off trying to be a social gadget creator in the browser for their proprietary platform that was there. And they put this out, and they started getting users to sign up for it. And the users said, hey, it would be great if you could support Java. It'd be great if you could add some Maven support. Wouldn't it be awesome if you could deploy to Google App Engine? And so they just kind of kept tinkering with it. And by the middle of 2011, they actually had 10,000 users on this thing that was kind of tinkering around. I was on the board of this company, and we were trying to run the company, but we found ourselves spending a lot of time looking at this side project going, why are people using an IDE in the browser? That makes no sense whatsoever. Out of curiosity, how many people here prefer IntelliJ? Third, in Eclipse? More than a third. Sublime, anybody? Oh, a couple of hands on there, right? NetBeans? One NetBeans guy. All right, I'm sorry, you're wrong. Oracle's shutting it down. It's going by the way of the dodo. Yeah. Doesn't support the database. What can you do? So interesting, right? We all have our preferences, we all have our biases. So we just for the life of us couldn't figure out why was this interesting. At the same time, there's this very impressive bio that makes me look like I actually know what I'm talking about in Java. I actually don't. I mean, I did at a point in time. And then my ambitions got the better of me, and I did what all engineers who are ambitious do. They become product managers. And when you become a product manager, you run around thinking that you know what you're talking about, creating a bunch of products, but you're really just depending upon the engineers to do their work. And I spent a good 6 or 7 years doing product management, and got to the point where I started doing investments, mergers and acquisitions for some large companies. And as you can see, I've done some investments and I sit on some boards. But there was a point in time, about 2011, where this IDE thing was kind of taking off, and I was getting frustrated with management, and I wanted to recapture my technical skills. And so I said, well, hey, I had written a book on Java EE at one point in time. I was very knowledgeable in this space. I was publishing almost twice a week. So I sat down and I'm like, how far could technology could have possibly gone in the 10 years that I hadn't been coding with it? I started to do Eclipse, Tomcat, and a basic Java EE app, and 5 days later I still did not have it working the right way on that. And it was very frustrating to me. And that's when we realized that there was a really big problem in this space. And we said, you know what, there's something more than a Cloud IDE here. There's something special about what's going on. And we began to, we actually threw it away. We threw away the product that we had. We basically put it into maintenance mode. That product is still online. You can go to codeenvy.com and log in and use it. It actually looks pretty good. It looks like Eclipse. It looks like a Cloud IDE. But we immediately raised $9 million. And we expanded the R&D team to about 40 people. And we started work in the beginning of 2012 on building something different. And just now we've kind of hit alpha, feature complete with all this stuff that we've been working on, about 100 million years of effort. And I'm just now kind of poking out at a couple of Java user groups to get first impressions of it. So what I'd like to do here is just kind of walk you through some of our theories, give you some demos of stuff, and then open it up for Q&A and tell you what you think. We're actually, as a company, just real quick, we're 50 people. We do our engineering in France and in the Ukraine. Hey, see you later, Steve. I've traveled to Ukraine many times. It is a war zone. That is a very interesting place to travel to these days. Fortunately, I've got pro-European Ukrainians as opposed to the pro-Russian types that are there, so that's helpful. We're based in San Francisco, and we've actually got quite a few customers, including Google, Atlassian, WSO2 is a customer of ours. Walmart's going to become a customer. Intuit's a customer. So we've done some interesting things here. There is inefficiency in development. I love this. This is the quick start tutorial to installing the world's most popular application server with the world's most popular IDE with the world's most popular version of Java. And this, if you think about it, is the typical setup guide for most developers at companies. How many of you guys have a wiki page for your project, and when you get a new developer and he says, like, great, I'm ready to start doing some coding, and you say, great, just go to this wiki page, and if you somehow survive the 67 steps on that page, you can then compile your app, right? Yeah. We've all had that, right? We laugh about that, but that shit is real, right? So it actually turns out that there was this fascinating study. It blows me away for engineers. This book, I just read it while we were sitting here, the Simplicity book. It talks about how doing things simply, right, and not doing things repeatedly. So why do we have these crazy wiki pages that require you to do the same thing over and over and over again? There was this crazy study done by Electric Cloud a year ago, and they interviewed 1,200 engineers. They used LinkedIn to do it. So these must actually be real engineers. And they came up with this fascinating stat. They basically said engineers spend a third of their time configuring their environments. And when I first heard it, I was like, I believe it. But I started quoting that to a lot of people, and every time I started quoting it to like a really good engineer, he was like, that is such bullshit. There's no way. I turn my computer on and it just runs. This is just, this is crazy. But what's really kind of crazy is that when you start looking at the things we do repeatedly throughout the week on a project, there's a lot of things where the configuration plaque or the configuration tax starts to add up slowly but surely. There are things that we all do. We think about the new project issue, the crazy wiki that's there, but how often do you have to change a branch? And after you change the branch, what are the things you got to do to get the new branch to compile, run, and debug? If you use Eclipse, then you've probably been through the nightmare of having to update the plugins and seeing that the plugins update differently than Eclipse itself, and it doesn't take long before you're uninstalling everything and reinstalling it to get to work correctly the next time. Have any of you had issues where you have a desktop and then even after you have everything running, you kick off like a massive compile, and the compile is consuming so many resources that it's thrashing the rest of your computer. So now all the other applications that you need to run, guess what, are slowing down because the thing that you're compiling on your computer is consuming all the compute that's there, right? Some people try to solve this with Vagrant. Anybody using Vagrant or Boxen? Okay, got a couple of Vagrants, right? Okay, so now you have this image, and you can download this image, but now you've got to keep the image synchronized across all the members of your team. You've got to download it, and even after you run the image locally, you still have to connect it to your local IDE. So there's time that adds up. But when you get into the team level, you have a lot of tribal knowledge, right? As the team grows, there's usually one or two guys who are the knowledgeable guys who know it all, right? And so now everybody else is kind of sucking their time down, trying to get help to get things configured. You've got incompatibilities with your device when you want to move the environment from one device to the other, and you've got environmental technical debt. The older the project gets, the harder it is to reconstitute it, right, to get it back to the point where you can compile and debug it. And so it just starts to add up. And then, on top of that, and security guys are really crazy about this, particularly at large companies, they have no record of what you do with their code, when you check it out onto your computer, right? So they use this source code system. They have a log of all the checkouts, but they have no record of what you do with the code on your computer. I cannot tell you how many large financial institutions I've talked to, I find this crazy, where they go, yeah, you know, I've got like 10,000 engineers, and you know, I'm talking to you because I've got 800 of them in China. They're our employees. We totally trust them, but is there any way we can keep them from checking out the code, keeping it central so that you can prevent them from copying it and stealing it? And they say this all the time, right? There's their employees, they trust them, but yet they don't trust them. And so they want to keep things quarantined. So the more things you put onto the desktop, the less control they have. So there's these crazy things that line up. And so instead of building a cloud IDE, we realized, you know, the pain point here is this configuration tax. And it builds up, and we've just become accustomed to dealing with this. And so, you know, we're in the business of building developer environments. And instead of building developer environments that go onto your desktop, we're building those developer environments as a cloud. And when we say developer environment here, it's way more than an IDE. I mean, the IDE is the editor, the debugger, right? It may have a compiler with it, but if you want to provide a developer environment that is comprehensive and complete, it needs to have everything. The build system, the unit test system, all the plugins that the developer requires, the hooks to the SCM client. It's got to have the project, the source code, but it's also got to have a runner. It needs to have the application server, the database, everything necessary so that after the environment is set up, you hit build, and then you hit run, and it should work. So here's how we think this should work here. First, an developer environment cloud should be one where you can provision a new developer environment instantly. There's nothing to install, nothing to download, nothing to maintain. After the environment is provisioned, it should be completely comprehensive, and it should compile each and every time. The provisioning can take place over API, over CLI. And then once you've provisioned the developer environment, if the interfaces are well structured and well understood, it will work with any IDE. You can work with Eclipse, IntelliJ, Sublime, NetBeans, or if you don't want to mess with having that editor locally, we're going to provide a browser IDE as well on top of that. So IDE agnostic, but when you have the interfaces well defined, now the developer environment can interface with your issue management system, your source code management system, any tools that you've got. Once it's provisioned this way, then clone, embed, and share become frictionless. You can clone with a single click, you can share it with others with a single click, and privacy controls, access controls are then managed by the system itself. If it's done as a centralized system, then scaling the environment becomes linear as well. You can add RAM, you can add queues for parallelization, and you can structure it in such a way so that there's no thrashing, there's no dependency upon the client that you're using to interface with the system, and it has all the resources on demand exactly to match to specs. And then, if you all have your own developer environment, we can consolidate them into one cloud and run all of that activity on the minimum required hardware so that you get an incredible density on it as well. And then once you do that, you can apply management principles, extend it with plugins, or do analytics for tracking on that. So that's the high-level concept. And I'd like to show you guys a couple of demos here. Let's see if I can. Is that readable? Can we dim the lights just a little bit, or is that?
Turn them off.
Yeah.
Well, that's. I don't know if that's a little bit or not, but that's certainly an option here.
That is the only option unless we get the lecture.
So I was having some slow download times. We'll see how this goes today here on this. I'm going to go ahead and create an environment the hard way here. We've got some long ping times here. Generally on a high-speed connection, this will load in about, this should be instant here. And the IDE itself will load in about 8-ish seconds on that. What we're doing to start off with is we're going to just quickly come in here, and I'm going to create a Spring application. Call this the San Diego Jug. We're going to make it public by default here. We'll save this, and this is just taking one of the sample apps. There we go. I already did that name. All right. Notice that once the project is created, a couple of things are happening here. This is a browser environment. There is a URL here, so the project itself is given a unique ID. This URL is shareable. I could send it to you because it's a public project, and any of you, and then you can gain access to the very same environment at the same time with this. The other thing is that it's very responsive. Don't worry about the errors. This is an alpha. You're going to see all sorts of bugs. It's expected. It's expected. I'm going to charge you for that. But it's very responsive. In fact, the technology has come far enough now where we can make this as responsive as any sort of desktop environment if necessary on that. Other thing that happened is, if you notice, it kicked off this dependency successfully updated. I didn't click anything for that. So it automatically detected that this was a Java project. It saw that there was a pom.xml. It associated a Maven builder with it. I didn't have to select that. And then it automatically kicked off a dependency analysis. The dependency analysis takes place on servers that are not related to this editor. So the editing is taking place on some servers, the dependency analysis takes place on another, and it went and got those dependencies that were there. Some nice latency here.
What's the underlying technology?
What's that?
What's the underlying technology?
This has all been written in GWT, Java and GWT here. So you get a Java file here, and you can do interesting things like I can hit Control. We have some latency issues here, but when you do a parsing, it does the parsing on the server side, and then it sends over the abstract syntax tree, and then it caches it in the browser. So it's not done here.
Is it using Maven archetypes underneath that you have to generate that project?
No. This is, I'll explain. It's not doing that here at all. It's doing something different here.
Do you have any plans to support an offline mode?
Oh yes, I'll show you that in just a moment here. There we go. So you can get autocomplete on this as well. But what's interesting is, let's see, where is the right file? Let's just grab a dependency here. This is a Selenium dependency. Grab this real quick. If I were to come into this part here, and I were to do Control Space, Control Space. No proposals. What's that? There we go. Okay. And then I can come in here. We can just add to this dependency. Make sure it's screwed up right. Hit save. It's smart enough to detect that there's a dependency. It's going to get that dependency, and once it's done, we've got some pretty heavy latency here in this environment. You'll be able to you'll see that there's a different list down here, and somewhere in here is the Selenium classes. Oops. They're in there, trust me. This is the issue with, like, if I could go zoom out, it's a lot better. But, okay, so that's part one, right? So now what's interesting is let's do a run on this. and I actually think that this is gonna go a little wonky on me here because we ran into one of our unusual bugs. But when you do run, now what's interesting is you need a runner, and you're in the cloud, so you need to detect what kind of application this is, and then you have to create a virtual machine dynamically, which has exactly the right software necessary to run this. Take the artifacts, which is the WAR file here, deploy that into the virtual machine, and then create a runner URL. And that's exactly what we have here. There's a runner URL. This thing is running here. And it says hello. But I don't know if you saw this at the top. Has anybody here ever heard of Docker? A couple of people have heard of Docker, okay? At the top here, what's interesting is that if you're doing development in the cloud, every developer could have potentially an infinite number of runner configurations that they may want. You don't know what you need in your virtual machine until you create the project. So if you're going to make this usable in a configurable way, you need a way to allow the user of the system to create their own runner VMs. And you can't use those from some library that we provide. You've got to be able to create those each and every time. Docker is a technology that allows you to create recipe-based virtual machines. And it does it in a lightweight container, a Linux container that's there. These Docker commands are actually the system taking the recipe and executing that recipe to create the image on demand. I can click this button here, and it brings up, this is the Docker recipe itself. And what this says is grab from some coded image. This is like a base image from us. And then you're going to add the WAR file into it. You can certainly do that. This is a very simple version of that. But with Docker, you can put anything in there. You can install any kind of software. You can execute any sort of command that you want. You're able to put CLI clients in there. And so you have full functionality. And the system will honor that recipe each and every time. Once the runner is running, you have a terminal. I know our color choice here isn't the best, but this is a full bash terminal into the runner that's there. Maybe LS will give us some better colors there. Right? So now you've got a secure shell into that runner that's running. And if we needed to, we could stop this. And because everything's in the cloud, you don't have to install anything. Right? So now you can come and do a custom run. That was with Tomcat, or the default. If we want to, we could change this to Jetty, run this, and what's actually happening is, okay, now it's grabbing the Jetty Docker recipe, creating that. It's going through the process of creating that virtual machine. The virtual machine has been created. It looks like it took 558 milliseconds to do that. And as soon as it's ready, it gives us another link, and now we've got that same application running here at the same time. Right? Because this is in the cloud, you're not bound to a single machine. This is running on a cloud system, and so all of your run commands are put onto queues, and so you can have as many queues as you want. So one of the things that it's not available in this interface here, but you can have multiple queues for your workspace. And so what you can do is you can say, I would like to have 6 queues. Each queue is going to have their own runner. And what you can do is say, I would like to run this application with all 6 of those application servers at the same time. And so it takes the same run command, puts them onto each queue, and then each queue processes it, and it gives you back 6 runner URLs so that you can click through and run them all at one time. Right? So the parallelism that is available once you go into the cloud is much more extreme as a result. Okay, so if we wanted to create a new file, this is our format for overwriting the default here. And it turns out that if you put this file into the root directory, no, we don't want that. We want take this. If you put that file into the root directory, then you can provide custom Docker files. And so there's a whole language around Docker. And essentially, what this does is this starts with a basic JDK7. It's going to run a make dir to build a directory called jboss7. Then it executes a wget command to actually download jboss from the internet. Then it runs a series of commands to extract it. It does some set actions on it. It opens up port 8080, sets the working directory to this directory, executes this command, and then copies your war into it as well. So what's interesting about something like this is that here, through these scripts, you can now create whatever kind of runner image that you want to have, and you can do it on demand. You can save it. You can stop it. You can run this, and now you're running that custom. Oh, what happened there? I must have misformatted something. Okay. We have limited time, so I'm going to continue on. So you get that. Full Git and subversion capabilities, full data source capabilities, right? So basic developer environment. Now, collaboration is a really big deal. Let's just kill this. Here we go. There we go. So collaboration is a really big deal. So you're going to want to be able to share this. So what we did is we basically took these configurations and we put them into these things we call factories. And factories are cloning templates. And so a factory is a URL, but inside that super long URL is the entire configuration of the project exactly as you've left it. The source code, the project type, the builder, the compiler, the unit test system, the runner, it's all there. And so when you put that into a browser and you hit enter, what ends up happening is it recognizes that and it says, oh, this is a cloning template. We're going to go and create a clone of that other project and we're going to put it into a temporary workspace. So, we're having all kinds of issues tonight. That's not good. That's really bad, actually. That failed. Try one more time. Yeah. Well, at least it's the same issue repeatedly. It's a good bug, yeah. It's just, no, I'm pretty sure that the engineers updated. I'm not supposed to be on this system. So, there's a system that they give me that is I'm supposed to use for demos, but it's like 6 weeks behind where engineering is. And so I'm always like, oh, but I like those features that you've done. So I always get myself into this trouble, and I do this. And it's really not smart. Yeah. Yeah. Oh yeah, we're having all sorts of issues here. Lost the factory panel. Yeah, it's all kinds of interesting stuff. This is good. They need to come to San Diego to test this stuff. I think it's actually the low latency. Like this is a really high ping times, and we haven't had some of these high ping times. I think that's somehow affecting this. But okay. Anyways, the way that factory is supposed to work. I've got some other ones here pre-made. Let's just go with the Apogee editor here. It's another factory, and assuming that it's not the latency of it, this is going to create a temp workspace. You can see the temp nature of it up here. It's created a temp. It is smart enough to see that it's a temporary environment, which means that if you don't save your work or you close the tab, it's all going to be deleted. So if you need to, you can persist it, right? And persisting, it's going to copy it into your account workspace that's there. But in the meantime, this is a total hack space that's here. And it's fully functional as well. These environments can be public or private, so you can put really strict access controls on them. You can choose to invite developers or restrict the developers that you've got. Beyond that, we've built a CLI, and so the CLI, someone had asked about offline mode, and what the CLI does is it allows you to log in. You can execute remote commands, so you can do a remote build or remote run. You can also do a sync point, and so you can take any project that's hosted in the cloud and it will sync offline onto your local desktop, and so you can use your IDE directly off that sync point, and then your changes to that local sync point are pushed back to the cloud. And also there's some 80 APIs. We have APIs for every developer atomic: build, dependency analysis, unit test. All those sort of functions have been represented in a very structured set of APIs. And so that then allows us to actually create interesting other types of clients. I'm going to leave this page, and this is a quick video I'll let run in the background while I talk. But this is an Eclipse plugin we're about to ship in a couple of months here. And this is actually a plugin inside of Eclipse that will synchronize your local project inside of Eclipse with the remote project as well, without having to use the sync point on the CLI itself. So here it logs in, it gets a list of all the projects that are running in the cloud. It opens up the project space. Keeps the stored credentials. You can keep moving these projects back and forth. And then you can trigger builds and trigger runs and have all the output that's taking place on the cloud actually piped back and streamed into the system that's here. So there it's doing a remote build, and you can see it puts it on the queue, it executes the build, you get the output, there's the WAR file from it, and it's all good, and then it repeats the same exercise for the runner as well. You'll actually see him do a run. You see it sit on the queue for a while. It's waiting for a slave to take it. And then after it picks it up off the queue, you're going to see the output in the top half of that window there once the run kicks off and actually executes at it. So there you go. It's a remote run piped right back into Eclipse as well. What we're hoping to do is we've also built this for completely on-premise. So this is deployable. We've got a very sophisticated installation system so that it can be deployed by enterprises either in a single server mode or as a distributed set of servers that's there, so that companies can create their own custom workflows with this. And it's our intention to ship most of this stuff hopefully by the end of this quarter. And also we just got to the point where we donated almost all of it to Eclipse. And that project was just accepted a couple of weeks ago, and it's going to be called Eclipse Che, which is a great name, Eclipse Che. And there's going to be a top-level project at Eclipse called the Cloud Development Platform, and IBM, Pivotal, CodeIndy, SAP, and Red Hat are all going to be contributing on that. So this is going to become, we hope to become a pretty big standard. The underlying architecture, when you get this, you can go to our GitHub page and check it out and just do a Maven clean install and build this thing. It's actually very similar to the Eclipse architecture, meaning that it's just a set of plugins. And so we've got a very lightweight kernel. And the kernel just executes these plugins. And if you rip out all the plugins, it's just a really simple web app. And so you can write extensions to this system using Java, CDI, Gen, and Juice, and GWT, and you write them as very simple classes. You deploy them, it runs in any servlet container, and then it generates the tooling the same way that Eclipse generates SWT for its rich client interface. This generates cross-browser optimized JavaScript and also all the REST APIs. And it's structured in such a way that when your services are deployed into our cloud, it distributes them for scale as well. So that's that. And with that, I've got like 20 minutes left, so I'll pause there and open it up for questions and comments on what you think of this sort of stuff. Probably turn on the light.
Yeah, it looks amazing, but were you considering that your competition is going to be against free products?
I think of my competition as mostly do-it-yourself.
Yeah.
Do-it-yourself configuration and enterprises. Secondarily, I think Vagrant is a type of competitive offering, because if you're using Vagrant, you did that because you're trying to solve this automation of a setup of environments. But it's not solving the problem, because you're still forcing all your users to download this really heavy image and then to run a hypervisor, which is really inefficient as well. So I think they're trying to solve the problem, but it's not a complete solution. And I think almost all the desktop IDEs are complementary. I think this fits into what people do. And I also think that this opens up development to a lot of developers, or a lot of contributor developers who want to help code but can't. So for example, QA, graphic designers, product managers, project managers, these are all people who would love to be able to get into the code and get it to compile and run. Today, it's way too much of a barrier for them to get the environment set up. But if you can deploy this and have the sysadmin create the environment and then just create that factory URL to send to everyone, you can have these URLs available for all the team, and then more people will gain access and know how to compile, commit, and participate as well.
I'm not sure I want that.
Yeah.
But it's a nice vision. So what's your pricing strategy?
So it'll be free. So we have three ways to make money, really. In our public cloud, it will be free for unlimited use, unlimited private projects, and unlimited storage, but we will cap your RAM for the runner at 1/4 gig. And so then you'll get 2 gigs, then we'll have premium offerings, and we sell anywhere from 2 gigs of RAM up to 4,000 gigabytes of RAM. There's different ways you can chop that. So one, you can have the RAM allow us to turn off your runners very aggressively so we can conserve resources. That's a very cheap price. Or you can say, I want my runners on 24/7 as always on, and then that's a very expensive price. And then you can also get an organization add-on, which allows you to take the RAM and chop it up for the team. So you can create multiple workspaces, and you get 8 gigs, you get 10 gigs, and that's where the 4,000 gigabytes of RAM for teams. So that's one. It's my plan to run my public cloud at a break even, or probably at a loss. The public cloud is really just to kind of prove that we can run this at scale. My second money making is we will sell support and an updater service for on-premises. So if you're going to deploy this on premises, it's a full cloud. There's a minimum of 10 servers if you want to do the distributed setup of this. So we have an installer, we have bi-weekly updates, we provide the support and the maintenance, and that'll be a per user fee. The per user fee is about somewhere between $150 to $200 per year on that. And then the third way is that we're doing a lot of business right now with ISVs like Google and Intuit, other companies that are selling to developers, and they're using this and creating custom cloud environments with it. And so those are OEM arrangements.
So how do you envision this coexisting or fitting into AWS?
Oh, well, we run, we support any infrastructure as a service. So our public cloud actually runs on this, everything we just demoed here is on top of EC2. But the updater service that we've created, we've tested this on Google Cloud, vCenter, OpenStack implementations. We're pretty much, our installation point is CentOS. So as long as you give us a set of nodes that have CentOS 6 installed on it, we're able to work in that environment.
And you mentioned starting up a bunch of nodes, a bunch of runners. Could you start up a set of different runners, like start up a web app and a bunch of web services that it's going to call?
Yes. So inside Docker, for example, can be a multi-process image. So inside of Docker, you could have, when you create that image, you could have a database running, you could have an app server running, you could have multiple app servers running in a cluster inside of one image. Or if you wanted to have 2 queues, you could have each queue with a different virtual machine, and those 2 virtual machines are running different software that then have a sync point with them on that. So the underlying technology is quite flexible in what you can do on that.
What about multi-layer or multi-tier architectures? Like you have web tier and then link tier and then ESBs and databases. things like, for example, if we're using something like a typical ESB, we have.
Well, let's talk about the WSO2 ESB, in fact, which is probably one of the more, let's see, I'll get a good load here. So yes, you can have pub sub, right? You can have distributed services running, right? Crap connection here. This should be instant.
You can use the local.
Oh, it's okay.
This AT&T?
No, it's their corporate network here.
So new network.
Sure you have
Anyways, what this shows is not only is it distributed by nature with load, actually the editor is a drag and drop editor as well. So it's an ESB sequence editor. There's mediators in there. You connect mediators together. It's drawing arrows together. It opens for us. Yeah, but even then, like these should be instant, right? So that's all the lag time.
You're welcome to come back. With a very long cable.
Yeah. See, you can get drag and drop capability, and this is in the browser sort of thing. So I'm really not supposed to show this yet, but they're going to ship this in about a month. So so now whenever you install their ESB, they'll have a link, open it up, and now you can create ESB sequences without having to install anything on Eclipse and their complex plugins and stuff like that.
Do you expect most developers to use the browser interface, or do you go offline?
I'm trying to stay out of it. I think that primary developers, when you have your primary workbench, everybody has their biases for that. So we want to have total support for all those primary workbenches. I think that if you think less about what do I have as my environment, and more about if we can make provisioning new environments cost frictionless, meaning the time to do it and there's no effort, then I think you can start thinking about having environments per task. So imagine going into, anybody use Jira in here, Jira or Bugzilla, this thing? Imagine going into every issue in your bug system, and next to the issue you had a link in there, and that link, when you clicked it, opened up exactly the code system that you needed so that you can work on that issue, or you saw the historical issue commit for that. So eventually, once we really nail this protocol, we're going to start building plugins for those systems. And so I think in that situation now, it's less about, do I want to use IntelliJ? It's more of, hey, I was just looking at this bug. I want to click it so that I can have a hack space for it, and I'll use it in that regard because it was more efficient. And so I think there's certainly use cases where there's more efficiency for using this, and I think then there's the kind of the long-lived development use case where you need a very serious workbench that you want to set up. And so I think they can coexist in that world.
What about personalization? Let's say as a developer, most of the time, you can use the same IDE, but your environment will most likely look very different from mine, right?
Yeah.
Because you like different color schemes and stuff like that. So
Yeah.
so
This is kind of an old version that's running here, but the personalization that we'll ship in the browser IDE initially will be white and dark themes. There will be 3 different editors. So you can use the Google editor, the CodeMirror editor, or the Orion editor. And these are very sophisticated editors. Like for the CodeMirror editor lets you do Sublime key bindings, including multi-cursor support. It comes with code folding, syntax color highlighting. It's got VI and Emacs as well. So I think those editors, which are kind of off-the-shelf, well-regarded browser-based editors, give you kind of like 75% of what most developers would expect in the personalization front.
but can I personalize it to my likes or dislikes?
Key bindings, yes. Colors, yes. Beyond that, you can write a plugin like you would in Eclipse, and then really go to town with it. Because everything can be overridden when you write a plugin and deploy it at that point. But we certainly don't have the level of customization plugins that Eclipse has, where you get really fine-grained control over it at this point. I think one of the big things, because we're going to, we're 40 engineers, there's like another 10 that are working on it. we're going to Eclipse because we really want to try to get contributors. We want to bring the community in to help us work on the SDK and add these sorts of things that people expect out of a system like this. By the way, we haven't talked about it, but usually when I've got like a great environment, I'll get like 15 tabs running up along, and on average, I'm consuming about 90 megabytes of RAM per tab on this. So you can be running a lot of concurrent developer environments and not consume over a gigabyte of RAM on your system here. So it can be really effective.
What do you do if you have like a 100 people company and they all compile at the same time?
So we do what we call separation processing behind the scenes. So when I said it's 10 nodes that the system is running, actually it's 10 clusters of stuff. So we have a cluster dedicated to code assistance, which is the autocomplete. There's a cluster dedicated to data sources and API invocations, one for builders, one for runners, one for editors, right? And so what happens is that even though it seems like it's just one server that's going on here, behind the scenes the system is partitioning the jobs off to these clusters, and then the queuing mechanism takes care of your order and the sequence that you have. So if you're the sysadmin and you set this up and you have one builder node, and you've got one queue on that builder node, everything is single file through it, right? But you could also set it up to have a builder cluster of 3, and you could put 6 queues on it, give one queue to each person, and then you get that, and the system takes care of the routing and traffic as a result on it. And it's that sort of capability that gives the density. If you think about it, when we do development on our desktop here, it's the most inefficient use of resources that you could possibly imagine. And the reason being is that when you're editing, it's incredibly I/O intensive. When you're building, it's CPU intensive. And when you're running, it's RAM intensive. You're rarely doing all 3 of those at the same time. So at any point in time, you have a ton of physical resources that are sitting idle, unused. But when you put this at a cloud, you can have runners, builders, all those things separate, and you're getting maximum usage of those of the machine for that purpose at any point in time. And at the same time, the developer is getting to use like up to 6 different computers simultaneously without it thrashing or blocking each other. And so you get, as a result, a much higher density and a much better experience.
Within the cloud, but then within your laptop, you're getting even lower density, and that's
It's
still
another
there
benefit
part
on top of that as well, right? Because you've offloaded you've offloaded this computer to be useful for other things that you want to do with it.
I mean, I guess my point is you still need that computer to connect to everything, so.
Yes, right. But now imagine
you don't get to like not have that in the.
No, I mean there has to be some client to engage with the developer environment at some point. But there's still 1 million developers around the world who are forced to do development through VDI. And so they wake up in India, they log on to some green screen, and then they VDI into some remote server, and then they're basically broadcasting a rich desktop client over the internet back and forth, and the performance is just horrific. So for them, this is a dramatic performance improvement.
Wow.
For everyone else, it's it's more about it's central, it's controllable by the sysadmins. You can do the backup and recovery. You can apply the permission sets, and then it makes hardware interoperability go out the door, and it really streamlines the cloning operation as well.
Do you guys actually use your tool to build?
No, we've written almost all of this in IntelliJ. It is possible. We do build it in CodeEnvy. The reason we can't use CodeEnvy to build CodeEnvy right now actually has to do with the limitation in GWT. So because we based everything on GWT, GWT has this super dev mode that you need to trigger to get incremental compile. Otherwise, every edit basically turns into like this massive 5 to 7 minute compilation exercise, and that's just not really doable. Good news is that I believe GWT 2.7, which is coming out this summer, finally introduces incremental compile for all systems, and once that's there, yeah, we can use it to build it there. But we do have an example, like when this ships, when we go GA in the project wizard, there will be all the CodeEnvy projects there, including the IDE, our user dashboard, the CLI, And so you will be able to run the IDE. In the IDE, you'll need I think what we're going to minimum require 2 to 4 gigabytes of RAM to run that. So you have to have an upgraded account, but it'll run just fine on there. And we'll provide an image that does the incremental compile, and it'll be great.
So your plan is to get all your people to switch over and build everything once you have it?
Our plan is to get all the people to switch over. I try not to tell my engineers how to live their life, but yeah, I mean we're pretty committed to this way of life here, right? Great.
There's no limitation if you want to use like a Chromebook as long as you have that browser in there, right?
That's right.
So does it work for all browsers?
Yeah. Our engineers haven't QA'd it on IE, but I use it on IE. They keep. I think it runs really good on IE, but they won't run the QA test. They won't officially support it, but I think IE 11 is pretty good. It also runs on the iPad and iPhone as well. There's really no restrictions to that. You even get fidelity of the, to a degree. There's a certain degree of fidelity of the design.
Do you have a speech to text?
Was that?
Speech to text.
There's no Siri. Right, my insert dumb algorithm here.
Can it bring me a beer?
So thumbs up, thumbs down, thumbs up. Yeah. Kind of thumbs up. Okay, great. Sorry for the latency issues. It is an alpha. That's my caveat to that. But we will make it. There is only like 120 known issues that we have to fix before we can ship. So that's we have over 3,000 that we've done. So
Great, thank you.
thank you so much. Stickers, my business card if you want to chat, anything like that.
I forgot to mention Tyler was sponsored Sullivan this evening.
I owe him $190.
Alms for the poor. All right, well, great. Thank you very
Thank
much.
you so much.
I'll support any company that refuses